Well, good morning, everyone. We appreciate you tuning in this morning. It's been a while since we've had one of these. Got on us with it today. We have Dave Gordon. Dave, you want to introduce yourself?
Good morning, everyone, and thanks for joining us. I'm Dave Gordon. I'm the Eastern USA Regional Sales Manager. Pretty much anything from Toronto down to Key West and over to the Mississippi. I'm here to help. I'm Greg's counterpart. Feel free to reach out to me for whatever you may need. I will be periodically putting my contact information in the chat. So should you have a question or a concern, please shoot it over to me and let me see if I can help you. My job is to do a complete design for you guys to make sure you have all the right components and so there's no missteps, which makes everyone happier when we're able to do a system flawlessly. So once again, my contact information will be posted throughout the webinar.
Thanks, Dave. And then Larry, you want to introduce yourself?
Sure. Morning, my name's Larry Barnes. I'm the Tech Support Manager for North America. I'm stationed in beautiful Dallas, Texas. So anytime you need assistance, please give us a call. There's 3 of us. Right now we're doing it kind of in a strange manner. You have to leave a voicemail, but we're about to get that fixed. We're going to upgrade some equipment where we can actually take live calls from home, and we'll try to help you out as quick as we can. All right?
Thank you, Larry. And on with us from time to time is Diane Maggart. She is our General Manager in Inside Sales, so you will sometimes talk to her and Terry there at the office when you call into the office. My name is Greg Penninger. I am Dave's counterpart, Regional Sales Manager for all things pretty much west of the Mississippi. There's a couple ins and outs that we have, but my contact information will be available as well, so feel free to reach out. We appreciate your business and working with us through these interesting times. Larry, you want to kick us off? We're going to talk about the 825 today.
Yes, sir. So what I wanted to do today was go through the AC825 IP. That's the newest panel in our lineup, and it is totally different in architecture from the old ones, and it often causes a lot of confusion. So wanted to go through, I'm going to go over the features and specs somewhat, but not in a lot of detail here. I wanted to try and go through the various configurations and the ways to use this panel today. So if everybody's ready, we'll kick this off here.
Make it happen, Captain.
All right. So the AC825, you've got the network controller itself, that is the AC825 IP. That main board, the box called the AC825, will support 4 readers, 4 Wiegand readers, plus 2 OSDP readers, and has 6 output relays. So you can technically do up to 6 devices, 6 doors, gates, etc., off of the base panel. But note, 2 of those readers must be OSDP if you're going to do that. Typically, if you're using standard Wiegand output readers, it's 4 on the motherboard. Then expansion boards, pardon me. The most common one, the D805, that's a 4-door expansion module. So 4 reader ports, 4 output relays. Now, and all the output relays, by the way, are all Form C isolated dry contacts, just like all of our old panels. So you can connect these directly to a gate operator. You can use an external power supply with it. You can use the internal power, which I'll go over in more detail in a minute. So the D805, that's your door expansion. You can add 1 of those to the AC825 box and have 8 doors in the 1 box. There's also an expansion chassis that you can put 2 more D805s in at a time, the ME1515. So you can put an additional 8 doors in that, and you can daisy chain those off of the base AC825, which allows you to expand technically up to 80 plus doors off of 1 controller. I never recommend doing that. I like to limit it to about 40, just so you don't have a single point of failure, because that AC825 is the only controller in there. Those D805s are expansion boards. They're called that because they're dumb. No control, they're slaves. You get the idea. sorry, RR805, it's a 16 relay output board. Typically, that's what we use for elevator control. You can daughter board this onto the AC825 with it and the relays on the main board. That allows you to control one elevator up to 22 floors. You can add additional R805s also as expansion boards, so you could go up essentially, you know, an infinite number of floors. Would get a little hard to manage at that point, but you can do it. The P805, we don't sell too many of those. That gives you 16 inputs, 8 output relays, and that was designed to allow you to function as kind of a PLC. So you can have input triggers, firing output relays, and control that all within the Axtrax NG. Where we see that end up being used mostly is people wanting to monitor doors that don't have access control on them and be able to lock those doors on a schedule and things of that nature. And then the S805, just 8 inputs, again, usually used for monitoring of doors that have no control on them, but you can set it up to do an alarm. So. Some basic specs. I just went over most of these. OSDP readers that we offer would be like the AYU 915, 920 long range readers and the AY H6255, 6355 CSN readers and our 6280 O2S readers. So we can do up to 6 in the one box. I put 40 doors. That's my recommended. That's somewhat less than what the engineering folks say we can do. But again, that's to keep it from being a single point failure. And I kind of stress that because I came out of the telecom world. Multiple interlock groups, I'll talk about a little bit more as we get into the software, but basically if you need a door interlock or a man trap, you can have multiple man traps that are essentially isolated from each other. You set up man trap groups of doors, and those the logic allows you to have those doors open when the others are locked down, that sort of thing. Elevator control, I've already touched on. Like I said, you can do 22 doors on a base AC825 with an R805. You can expand that further. Each AC825 requires its own LAN connection. You cannot daisy chain the AC825s like the old AC225s or 425s, etc. And you cannot daisy chain an AC225 to an 825, 225s and 825s via RS-485. They must be on separate networks. So that's caused some confusion out in the field several times. Just want to clarify that. The AC825 does use RS-485 to talk to its expansions, but it's only to its expansion boards. You cannot mix the two on the same network. You can have them both managed in the same instance of Axtrax NG. It's just your 225s will be on one network, the 825s on another. It does have an internal battery-backed power supply with output capability of 2 amps at 13.8 volts DC. So you do have power for locks, but you do have to keep it under the 2 amps. So obviously with 8 doors, if you have all mag locks, you're going to have to supply external power for some of those locks, but you do have some available. On a 4-door system with strikes, for instance, or even 8 strikes, you can probably get by without an external power supply. Here's all the detailed specs if you want to take a look at them. I'm not going to go through all of these. I've already kind of touched on the high points. This presentation will, by the way, be available in a PDF format later. So here's a picture of the 825 itself, the closed up and then opened up. As you can see, there's a lot of room around here for all your wiring. The power supply is down here in the bottom. Your auxiliary power for your locks is available over here. There's 2 terminal blocks. Electrically, they're the same. It's just to give you more tie points. Battery would go right here in the center, 12 volt, 7 amp hour, or 8. That size. can drop right here in the center of it. That backs up the power to both the panel and your door lock. So keep that in mind. You know, if you're looking at backup time, if you're powering all your locks off of the internal supply, that battery is not going to last near as long as if it were just powering the panel only, panel and readers. So. Up here at the top, one of the things, this is the first panel that got this. This is now in our B series panels also. That's a light bar up there at the top. The tamper switch, we can actually set up to generate alarms in the software, etc., is on it, but it also provides illumination inside the cabinet here. So if you are working back there in the server corner, back corner of the server room, excuse me, or in a dark closet, you will have some light in here to see what you're doing. And you can actually slip this out. It's just clipped in. If you can actually pull it out and use it like a work light or a flashlight inside the box here. So just a handy feature. That's available now on all of our new panels, by the way. So the AC825 board itself, Wiegand inputs, reader 1, 2, 3, and 4, all down the left side, with the outputs, corresponding outputs directly across from them on the right. Your LAN connections up here on the top left corner. Don't mess with the dip switch. Unlike our old panels, you don't set addresses here, you don't set anything, leave it alone. If you're going to mount a D805, R805 directly to it, you can see here there's a peel off cover that you remove, and you just peel that up. It's just self-adhesive, and then that exposes 4 mounting screws and the receptacle for the daughter boards up here in the center. Outputs 5 and 6, as I said, you can control those using OSDP readers, which that connector is down here on the bottom left. This one is currently not in use. There was plans to have 2 RS-485 ports. Currently implemented, the right-hand one is not used. So everything will connect here. D805s, R805s for expansion, or OSDP readers, both. This big LED down here, that's just a power LED, means the board is getting power. This USB slot right now is also not used. About the only thing it's good for is you can charge your phone on it. I have done that. But there are 2 LEDs down here at the bottom. If you do call into tech support and we ask you about the status LEDs, we're talking about 2 small LEDs down here on the bottom right. There's a red and a green. In normal operation, the green one should be lit continuously. It's actually flashing real fast, but it appears continuous. And the red one should be either a slow flash if the PC or the CPU is booted up. Excuse me, the AC825 is booted up. You'll get a slow flash when it connects to the server machine. That will speed up to about once a second. All right. D805, very similar layout. Readers down, Wiegand readers down the left side, corresponding outputs out on the right. There's a pop-off cover down here at the bottom that has your power connections, which we'll talk a little more about in a minute. Now, this is only used when it's being mounted out in the expansion chassis or external. When it's installed as a daughter board, you just leave this cover on and don't connect anything to it. That also has caused some confusion out in the field. When you plug it in, it's a slave off the main board, and you connect nothing down here at the bottom. All right. That's what I'm trying to show here. When they took the picture of this, they had the cover off, which made it even worse. You don't use that, just leave the cover on. The board is powered and controlled purely from the main AC825. Then the ME1515, the expansion chassis with 2 boards mounted, would look like this. So there's a power connector, which you can see, that's brought in here. There is only one supplied, so you will need to supply your own wiring from that one over to the second board if you've got 2 boards installed. And typically you would install the first board over here, because there's also 2 connectors you can't see in this picture. There's 2 small connectors that come in the back side here two small white connectors that have to be plugged into this board. One is going back to the power supply for power monitoring. The other one is going up to the light for the tamper switch and to power the work light in this chassis. This is just a picture of all the expansion boards so you can kind of get an idea. D805 I've already talked about. The R805 for elevator control, just a bunch of relays. That's it. The P805, they call it the PLC IO because we've got both some inputs over here that can be programmed to trigger outputs over here, and then the S805, just supervised inputs only, again, used for monitoring purposes. All of the boards come with a back cover, a mounting plate that is DIN rail mountable. And this is a picture that was sent to us by one of our other operations, where everything was done on a DIN rail. So you can see the DIN rail mounted power supplies, terminal blocks, etc. And then the main AC825 up here. And then I think they've got a total of 10 D805s external here also, all being controlled off one controller. So you can get more creative than just having the boxes. We haven't seen that much here in the States, but it is an option. And if you're familiar with DIN rail mounting, you can make some very nice compact installations that way. So here's the basic wiring. I'm just going to go across some, or go over some basic, some examples here real quick. 8 doors off an AC825, so you'd have your cabinet, one D805 in it, and wiring would come straight from here out to your 8 doors. Nothing special. LAN connection to the main AC825 only. You can have your battery backup in here, etc. If you wanted to add to that a couple of long-range readers, you can take outputs 5 and 6 here at the bottom, connect the long-range readers to the OSDP connection, and use that for gate control. Now, the long-range readers, the only caveat there is they do need to have the latest firmware on them. I believe everything we have in stock now does. There could be some out there in the field that don't. That's the only issue with that. Here's a larger example, 40 doors. So your first AC825 with a D805 would be here. And then coming off of the OSDP connector, you would go out to each D805 in a daisy chain format, all right? And one of the things I wanted to point out is, and this is critical, anytime you have external expansion boxes, even when they're side by side, engineering recommends that the first panel and the last panel have a termination resistor, which I'll show the exact connection in a moment in another slide. But basically it's connected across the A to B terminals on your OSDP connector. So it goes on the first one and the last one, 100 to 120 ohms. Power rating, 1/8 watt, 1/4 watt is plenty. It's just signal level, but you need that termination resistor because this is running at a fairly high speed. This cable also needs to be Cat 5 or 6 shielded twisted pair, and the data must be on a twisted pair of wires. It can't be spread across multiple pairs or anything. Wiring is more critical here because it is running a higher speed. So just keep that in mind when you're scoping out or planning this. You cannot run 18 gauge and expect this to work. Bottom line, it will not. If you call in to say you're having connection problems with your expansion boards and you run 18 gauge, I'm going to tell you to rewire it. End of discussion. So now here's an example of elevator control. One of the things, again, that with the way our elevator control works, you must have an AC825 for each elevator car, all right, regardless of the number of readers. And without going into the gory details of how it works, that's a requirement because of our software, the way it controls access to the various floors. So you would have to have an AC825 per car, and then an R805 with enough outputs for all your floors. So with this, you could control up to 22 floors. You'd have one reader connected into reader 1. You can use, if you don't need all of the outputs, you can actually use the other reader ports on this 825 to control doors that are close enough to home run back to the 825 panel. But typically this would be located closer to the elevator controller, so you don't have all that wiring running all over the building. But reader 1 is in your elevator car, and then all your outputs would be running directly to the elevator controller, and that's it. Reader car 2 would have its own AC825, same thing, reader 2 or reader 1 located in that car, and the R805 running to its controller, or to the controller for it. So very important, remember that again when you're scoping out. If you've got 2 elevators, you're going to need 2 825s. You can't just stack a bunch of R805s off of one controller and control the elevators that way. Another mistake that we ran into ourselves early on, not quite understanding the 825 operation. So if you're doing elevators for the first time, by all means, call tech support and we'll go through the configuration with you. We're always available for pre-sales or anything else like that to assist you, along with Dave and Greg. All right. I'm going to go through the elevator setup a little bit here real quick. The way we control elevator access is it's independent of your access group. The access group just controls which readers your card will work on. In this case, everybody would have access to the reader in the elevator, but to control what floors you go to, you have to develop output groups. And basically what that does is it's going to determine which relays are fired when a specific individual swipes their card, hence enabling those floors. So typically you'll always have one group that's all floors that would be used for supervisors, maintenance, master users, etc. And then you can have groups of whatever floors you need grouped together. So if you have a tenant that only gets access to floor 2, then you do a group that only fires the relay enabling floor 2. If you've got a tenant that has, let's say, floors 2 through 5, then you do a group that fires all of those relays 2 through 5. So it's very much like access groups. A single user can only have one output group assigned to them. So you would have to do all these variations and combinations that are required. All right. And to set up the output groups, so you would come into output groups, hit edit, and then you select from all of the available outputs those that you want to fire. In this case, I was selecting everything on my R805. They're labeled 1R through 16R in the software. I selected all of those, okay. For floors 2 through 5, I came back and I only selected the outputs that were used to control those floors. Now I only had one panel here. If you had multiple panels, you'd have to select all the outputs on each of those panels. So if you've got 4 elevator cars, in this one output group, you'd go through all 4 panels, selecting the relays to control those floors on that panel and add them to the group. Then the way you assign it to a person, so the access group, like I said, that just controls, do they have access to the elevator at all? You know, if they swipe their card, will it enable any floors, do anything? User selected output group down here at the bottom, that's where you just determine which floors this user can access, all right? And that's why I say, just like an access group, you can only have one selected, so you may have to have multiple combinations out there in your floor groups. All right. I'm going to go through some sample wiring diagrams here for the AC825, just for normal access control purposes. So like all of our other panels, the output relays are dry contacts. So you've got to pick up power someplace. The power supply module down there on the bottom right, as I said, both outputs are electrically the same. So you're going to jumper in power from down there. Now, some people like to put the switch in the negative leg. Doesn't matter. Dry contacts, totally electrically isolated. So if you want to do it that way, you can. I tend to put it in the positive leg. So I jumper the positive output down there at the bottom up to the common terminal on my output relay. For a strike, I'm going to come off normally open to the strike, bring the return from the strike back to the negative down there on the power supply. Simple series circuit, just like any other access control panel, nothing new. Reader wiring, again, standard Wiegand, red, black, green, and white. I have to use blue here. White obviously wouldn't show up. Optional door monitor contact on you'll notice on the output terminals. Now these are a little different than the old panels. So you have input A and input B. Input A is the request to exit input by default. B is the door monitor. So if you want a door monitor contact so you can tell when the door is actually physically opened and can set up alarms, say for held open, forced open, etc., you would wire that normally closed contact into negative and input B here. If you want to request to exit input, that would come in on input A. Don't see that much with strikes. That'll be on the next slide here with a mag lock. Now, your rec switch, you can have it any way you want it. You can wire it into the panel here on input A so that it triggers. That way you can use a momentary switch and it'll unlock the door for your normal, 4 to 5 second unlock period. Door monitor contacts, same thing, wired to input B. You can also put your rec switch out here directly in series with the mag lock, required by code in many places, and used a timed switch. So up to you, up to your code, but it's the same configuration except now the mag lock's connected to normally closed. So again, you're picking up power from here. Nothing new, it's just like our old panels. Now this one gets a little bit more involved because I was trying to show some more options. So if you've got a motion detector, I always recommend wiring that directly in series with the mag lock here. You can power that off the auxiliary power just like you're powering the mag lock, by the way, assuming it's 12 volts DC or 13.8. And I put that in series with the mag lock rather than wiring it back into my Rex input. If you've got a switch like our EX06, pardon me, that has 2 sets of contacts, you can put one directly in series with your mag lock, meets code. It's got a built-in timer. It also has an extra set of contacts to feed back into the panel. And the reason for doing this is that way when the Rex button is pushed, it does break the circuit to the mag lock. Panel's not required, meets code, all of that, has its own timer, but it tells the panel that the Rex button was pushed so you can still have your door alarms function normally. So it'll know, okay, the door opened up, but that was because somebody pressed the Rex button. So this diagram it gets a little more complicated, but basically I'm powering my EX06 off my auxiliary power and wiring both of them in series with the mag lock. Pardon me just a moment. So the next slides, I'm going to talk about the proper wiring of the RS485. The addressing on the dip switches of the expansion boards, the first board, you'll leave all the switches down. It'll show up as address 2 in the software. The next expansion board, if you have one, you'll set dip switch 4 up. That'll make it address 3. And there is a table in my, I don't know if it's in this presentation, but I do have a table that shows the actual all the addresses, but it's just a binary progression. I mentioned the 2 white wires in the back. And OSDP cabling, 100 ohm twisted shielded twisted pair, Cat 5 or 6 cable. So this is a slide I borrowed from good old Texas Instruments on RS-485 wiring. Backbone with stubs, you can do this, but those stubs need to be short. I mean, 6 or 12 inches, yeah. 6 or 12 feet, no. So the preferred way is to actually come into the board and come off like this on a true daisy chain. And that's what the manufacturers of the chipsets, the RS-485 receivers, recommend. These do not work. I'll just say it right now. They said avoid. We don't support it, and you will have problems, particularly the ring. That'll really cause strange things to happen. So coming off of my board, you're going to bring 3 wires. The data is on A and B, and that's the ones that need to be on the twisted pair. All right. Pardon me. And then the signal ground here, the negative lead. Now, typically what I tell people to do is just take another pair of wires, twist them together, and use that as the signal ground to run to all your panels. But the actual signal, A and B, needs to be on a twisted pair. So pick green, white, white, green, and run that out to all the panels in a daisy chain form or configuration. And then put a 100 ohm, that can be an 1/8 watt, 1/4 watt, whatever you want to use, something small, 100 ohm resistor across A to B on the first panel and the last panel. And as I said, if there's a daughter board, just leave the cover on, don't connect anything to it. The first expansion board, you'll connect power in the chassis on all of these. I didn't show that in here because I was concentrating on the signal wiring. The first board, and I actually should kind of reverse these, but the first board in the chain, you'll leave all the switches down. That'll make it panel 2 in the chain. The next board, you'll set dip switch 4 up. That'll make it panel 3, and so on. So on your next panel out, you would put 3 up, then 3 and 4, and so on. It's a binary progression, just like, and you can have, technically you could have up to 16 boards. I really don't recommend that. Okay. The slide off cover at the bottom, obviously, to get to it. The connectors I was talking about, if you look down from the top of the boards, there's 2 white connectors. This is also true on the main AC825 panel. If you had to replace one of them, there's 2 little white Molex type connectors on the very top edge of the board. That's where those 2 loose cables in the back of the ME1515 connect. Doesn't matter which one connects to the left or right, they're wired together. But you need to connect both of them to the same board. You can't connect one to one D805 and one to the other and things work correctly. All right. This is the matrix I was talking about for the address switch settings on the expansion boards. So all of them off is address 2, and you just go up normal binary fashion, 1, 2, 3, etc. up. One thing, when you are adding external expansion boards, you need to set all the dip switches with the boards powered down, power up the D805s, and then power cycle or then power up the AC825. It will not see them if you just connect them out there and power them up. You've got to reboot the AC825. It's got to detect them during its power up sequence to add them into the database. So. All right, that's my presentation for today on the AC825. I hope that's given everybody an idea of how to configure systems with it and some of the flexibility in it. If you have any questions, feel free to call myself, Greg, or David, either one, email. All of our contact information is here on the screen. As I said, on tech support, we're currently running everything to voicemail, and then we're calling back the voicemails as quickly as we can. That was because we all left the office for obvious reasons. We have elected to stay out of the office for the time being, so I don't lose anybody or out sick for 2 to 4 weeks. So We are upgrading our switch, and soon we'll be able to take live calls even from remote locations and get back to normal. So any questions, guys? Anything I missed going through that?
As usual, Larry, great job as usual, spot on. You know, as far as for people that are listening to this webinar, should they have any questions, like Larry said, our information's here available. Please reach out to us. And no such thing as a dumb question, only good questions. So reach out to us, let us know how we can help you. And with our products, you can make money with Roslayer. You can make a lot of money with Roslayer.
Exactly, and to echo what Dave said, Larry, great job as always.
Well,
You
thank
know,
you.
I think, you know, from a sales perspective, the 825 is such a powerful controller. It's truly an enterprise level solution. Then you have the ability to do so much with it, and as Dave said, it's a very affordable product. I don't think people realize just how powerful it is, considering the price we sell it for. So if you have not given the 825 a shot yet, please do give it a go on your next, or get with Dave and I, and we'll help you put together a bill of materials in your next install, and you can take advantage of some of these features. Larry, what would you say is your number one tech support question with the 825? Put you on the spot, kind of a.
Oh, no, actually, I kind of forgot to go over a few things like that myself. The number one tech support issue that we have with the AC825 today is it does require the networking with the AC825 was done a little differently to speed things up, because you're handling so many doors. So it requires direct access to the Xtract server process back on the server machine. So there is a firewall rule that must be implemented on the host machine where the Xtract server is running to allow the AC825 to communicate directly with the service. And that's a break for most devices out there, and certainly our older panels that did not require that. So if you download the software from my website, xtractsng.com, which I didn't go over either, there's in the zip file that you download, there's a little batch file script that will work on most PCs. If you run it as administrator, it will create the needed firewall rule. If it doesn't work, there is instructions there also in a little text file on how to create that rule yourself. That's probably the biggest thing we run into out in the field is don't put that rule in. You'll see the panel on the network. You'll be able to set the IP address and everything, but it'll keep coming up network inactive, and you won't be able to update the firmware and things of that nature. So that's the biggest problem or issue we run into, the most common thing. It's easy fix. You run that little script file, and it'll set your firewall up. I mean, other issues on it is just people not understanding how to daisy chain the panels properly and wire them properly, and that's why I wanted to go over that in detail today. You know, the RS-485 wiring people are used to on a lot of older devices, being able to use almost anything, house wire, 18 gauge zip cord, whatever. That will not work at the speeds that we're running the data over the RS-485. It's got to be, you know, good data grade cable like Cat 5 or 6, twisted pair and wired properly, or it will not work. And you know, as I said, if we get in there and we're having communication problems with the expansion boards, first thing I'm going to ask you is what kind of wire, exactly how it's wired, and then do you have the termination resistors? If the answer is, you know, not correct on any one of those, I'm going to stop. I'm going to tell you to fix it, bring it up to spec, because it will not work properly. No.
Well, I do want to compliment you on that download that you have at xtractsng.com, because it makes everything. I've got a lot of comments. It makes everything you need to install Xtract or get everything set up is all in that one little zip file. It makes it super easy for the tech in the field. One item to download, everything he needs is right, or he or she needs is just right there. So great job on putting that together for him.
Thanks. Hang
You're
on just
welcome.
a second. I'm going to
I think another thing to add to this is, although Larry touched on it, it's important to note that should you be doing elevator control, you definitely need one 825 and one R805 per elevator bank.
Yes.
Or elevator car.
Yes. Good point. This is my the website I was talking about, extractsng.com. It's the name of our software, is where we pulled that from. Rosslayer was kind of already taken by corporate. This is a portal I put together several years ago just to get the software. I've always got the latest version. This is the download I'm talking about. And it is a zip file that what I've got in there is not only the latest version of the software, but I've got some other tools. As I said, I've got documentation that I put together on how to install the software that I think is a little easier to read than the long-winded, gory documentation we get from engineering. And I've got the batch files for doing the firewall rules and some things like that. So there's quite a few documents included in there along with the latest software. So also on my web page, I've got links to some older videos and guides here. These are PDF files. Some of them are getting a little dated, but they're still appropriate. And some older videos that my predecessor David put together. And then I've got links here on the main page to the current YouTube channel that Greg is supporting now and uploading our webinars and such to. Also to a knowledge base that's being managed out of Israel. And this we're adding to every day with, if you need to look up a question or you have a question, can't get a hold of us, go here and do a quick search. It may very well be in there. All kinds of questions you can see here. There's the popular articles, ones that have been hit most often. So this is kind of a portal for all things Rosslayer, copy of our access catalog, list of credentials, etc. Also contact information down here at the bottom. You can email tech support directly here, email sales directly. You can also access our Facebook page that this is being recorded for, and some other tools and such. So that's my other little contribution to the cause. Oh, and TeamViewer. If you call in for tech support, what we really ask is just go ahead, if you're working on an install particularly or something like that, get TeamViewer ready, come to my website, download it from here. This is TeamViewer Quick Support. It doesn't have to install, and when you close it, it's gone. So it's not like we're leaving a backdoor on your PC in any way, shape, or form. Download this, run it, and have it ready for us when we get to you. That way, it just saves a lot of time for everybody. So, all right.
Well, very good, Larry. No, that's it. Lit for me anyway. Dave, you got anything?
No, that's a great presentation as always, and looking forward to the next one.
All right, guys. Well, have a good day. Everybody be safe. Be careful out there, and give us a call if you need any help.
Thanks, Larry.
Thanks, Larry.
Right.
Take care, Greg.
You too.
Bye.